Hello to everyone. In this video, let us discuss alkali metals, introduction, their general properties, and anomalous behavior of lithium, etc. Okay, first, let us see what are alkali metals here. In the first, that means in the periodic table, 1A group elements are called alkali metals. So, what are 1A group elements? Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. These are called which one? Alkali metals. And atomic numbers are here: hydrogen 1, lithium 3, sodium 11, potassium 19, rubidium 37, cesium 55, francium 87. Among all these elements, hydrogen position is doubtful in the periodic table because some properties of hydrogen are similar to alkali metals and some of the properties of hydrogen are similar to halogens. So, this position is still doubtful whether it is good to place either in alkali metals or in halogens. Okay, leave that. Now come to the another one, francium, that is radioactive element, and it's which one here, isotope francium 223 is the longest lived isotope of francium, that half life time is 21 minutes. So what is here the important thing means, in the properties discussion of alkali metals, no need to include hydrogen and francium because it is radioactive element and hydrogen position is doubtful. So our discussion of properties confined from lithium to cesium only. In between them only we have to go for which one properties. Okay, now these are the atomic numbers, and then general electronic configuration of alkali metals is which one means NS1. So this is the general electronic configuration of which one? Alkali metals. Now why these elements are called alkali metals? Because that first A group elements are having metallic nature and their compounds are having basic nature. For that reason, these are called as which one? Alkali metals. And let us come to the abundance or occurrence. Abundance or occurrence. Now, among all the alkali metals, sodium is the most abundant alkali metal. In overall, that is the seventh most abundant element, and potassium is the eighth most abundant element in the nature. Okay, that is regarding which one? That abundance. And one more important thing, due to their high reactivity, alkali metals are not available in free state. They available in compound form. Okay, now let us see another important thing here, that is which one? Anomalous behavior. Which will shows anomalous behavior? Let us see here. In representative elements, in every group, first element will shows somewhat different properties comparatively with other elements of the same group. So now in alkali metals, lithium shows some anomalous characteristic properties. I already given one hint to you, leave hydrogen because that position is doubtful to place whether in first A group or seventh A group. So now after removing that hydrogen, what is the first element in alkali metals? Means lithium. So lithium shows some anomalous properties. Lithium shows which one here? Some anomalous properties. Anomalous properties in which one? First A group elements. What are anomalous properties of lithium and what is the reason? See here. What is the reason? We have to see here. First, what is the reason means due to the smaller atomic size, high electronegativity, and due to absence of vacant d orbitals, lithium shows some anomalous properties. Let us see what are the properties here. The first one is here, lithium is the hard metal, but remaining alkali metals are soft, even they can cut with a knife, but lithium is the hardest alkali metal. And then second one, lithium is having high melting point and boiling point values, and lithium is of course less reactive, even though that is acting as a strong reducing agent, due to which one here, less that electrode potential, due to less electrode potential or more negative electrode potential, lithium act as a strong reducing agent. Okay, then another one here, lithium directly combine with nitrogen and form which one, lithium nitride. Lithium can form which one, lithium nitride, and lithium forms especially monoxide. Remaining oxides are not possible for lithium, but remaining elements will form. What are the other oxides means superoxides and peroxides, but lithium forms only monoxides. Okay, then lithium directly combine with carbon to produce lithium carbide, unlike other alkali metals. Other alkali metals do not combine directly with carbon. Okay, next anomalous property here, lithium chloride is deliquescent in nature. That means that does not lose a water molecule, unlike other alkali metal halides. Remaining alkali metal halides are, they loses water, but lithium chloride is deliquescent in nature. Okay, then another anomalous property here, lithium carbonate Li2CO3 on heating dissociate to give lithium oxide, carbon dioxide and oxygen. But other alkali metal carbonates are thermally stable. Other alkali metal carbonates like sodium carbonate, potassium carbonate are thermally stable, but lithium carbonate dissociate into oxide and CO2, and that will, okay, oxide and CO2 only, no need to write oxygen. So now lithium carbonate dissociate to give lithium oxide and carbon dioxide, but remaining carbonates are thermally stable. Okay, then another one here, lithium hydrogen carbonate does not exist in solid state. That does not exist in which state? Solid state. But remaining alkali metal hydrogen carbonates exist in solid state. Okay, then another anomalous behavior is here, lithium hydroxide LiOH is least basic in nature, and it is less soluble in water. Lithium hydroxide is having least basic nature, unlike other alkali metal hydroxides, those are more basic in nature. And then another one here, lithium sulfate. If you consider lithium sulfate, this is only alkali metal sulfate that doesn't form alums. This doesn't form which one means alums, but remaining alkali metal sulfates will give the alums. So what are alums we will learn later. Okay, then another one here, lithium chloride is less soluble in water, is less soluble in water, and it is more soluble in which one, organic solvents like alcohol, due to its covalent nature. And then lithium compounds are having covalent nature. That means lithium carbonate, lithium chloride, lithium sulfate, whatever it may be, almost all lithium compounds are having covalent nature, but remaining alkali metal compounds are having ionic nature. And another one here, lithium does not form acetylide by reacting with acetylene. Lithium does not form which one? Acetylide, but sodium form acetylide on reaction with acetylene. And one more important one is here, that is which one? Lithium nitrate, LiNO3, on heating will give lithium oxide, nitrogen dioxide and oxygen, but remaining alkali metal nitrates on heating produces metal nitrides and oxygen. So, lithium nitrate on heating produces lithium oxide, nitrogen dioxide, oxygen. But remaining nitrates of alkali metals produces what? Metal nitrides and oxygen. So, these are the anomalous properties of which one? Lithium. And then lithium shows diagonal relationship with which one? Magnesium. Lithium shows diagonal relationship with magnesium. What is the reason? Means here, due to the similar polarizing power, due to similar polarizing power and due to almost same atomic size and due to similar electronegativity, lithium is having diagonal relationship with which one? Magnesium. Diagonal relationship means here lithium properties are similar to the properties of magnesium. So what are the similar properties? Let us see here. Both lithium and magnesium decompose water. Both decompose water to liberate hydrogen gas. And the second one, both lithium and magnesium directly combine with nitrogen. Directly combine with which one? Nitrogen. Both lithium and nitrogen. And another one, both lithium and magnesium will give monoxides. Both can give which one? Means monoxide. Lithium give Li2O, magnesium gives MgO. And both hydroxides of lithium and magnesium, both hydroxides are least basic in nature. Both lithium and magnesium hydroxides are least basic in nature. And another one, both halides are deliquescent in nature. That means they retain water molecules with them. So like that, both that which one here? Both the halides of lithium and magnesium are deliquescent in nature. Okay, another one here, both compounds are having which one? Means that covalent nature. Same reason, due to which one here? Smaller atomic size, both lithium and magnesium compounds are having covalent nature and they are less soluble in water. Lithium and magnesium compounds both are less soluble in which one? Means water. Okay, then so these are, and another important one also there. What is that? Both carbonates decompose on heating. Both carbonates will decompose on heating easily. And another one here, that another property here, which one here? Both lithium and magnesium compounds are less soluble in water. They are less soluble in which one? Means water. So these are the some similarities between which one? Lithium and magnesium. So these are the similarities between, that means diagonal relationship of lithium with magnesium. So these are important topics. Then after that, let us go for which one, some physical properties and some chemical properties now here. So first let us see which one here, some general properties. First one is atomic size. We know that increases from top to bottom, atomic size. And then come to ionization potential, decreases from top to bottom. But here the second IP of alkali metals is much greater than that of their first ionization potential, because after losing one electron, each and every alkali metal get into stable inert gas configuration. So second ionization potential is much and more greater than that of first ionization potential. Okay, this is regarding ionization potential. And come to melting point and boiling point values. These are decreases from lithium to cesium due to decrease in strength of metallic bond. And another one, come to densities. Density increases from lithium to cesium. But one important thing here, what is that? Potassium has less density than sodium. Generally sodium increases from top to bottom, but potassium density less than that of sodium. Why? Because due to the presence of vacant d orbitals in potassium. So due to the presence of vacant d orbitals, there is a sudden increase in volume. As volume increases, what happens? Density decreases. This thing we have to remember regarding general properties of alkali metals. Okay, this is regarding density. And come to another one, electronegativity. Electronegativity decreases from top to bottom, and alkali metals having electronegativity less than 1, because they try to lose the electron, but they no need to gain electron, not interested to gain of electron. That's why only they have very less electronegativity value, less than 1. And that too, that electronegativity decreases from lithium to cesium. Okay, this is regarding which one? Electronegativity. Okay, then after that we have to go for reducing nature. This is important property for which one? Alkali metals. What is that reducing nature? Let us learn here. All alkali metals try to lose one electron to get into nearest inert gas configuration. That means by losing electron, they undergo oxidation, but they act as reducing agents. They act as which one? Reducing agents. Now among the alkali metals, as per our expectation, cesium easily loses electrons due to larger atomic size. So as per our expectation, cesium should have the more, that means a strong reducing capacity. Lithium should have the less reducing capacity. But a small change here. What is that means? Lithium is having strong reducing power. What is the reason? Means here, due to high heat of hydration, lithium is the strongest reducing agent in alkali metals. Then sodium is the weak reducing agent in alkali metals. So due to the high heat of hydration, lithium acts as a strong reducing agent. So what is the order of reducing power? Means sodium less than, potassium less than, rubidium less than, cesium less than lithium. So this is somewhat important here. So we have to remember that lithium is having strong reducing power. Reason is high heat of hydration. Okay, this is regarding which one? Reducing nature. Okay, after that reducing nature, let us go for which one means that ammonia solution. That means alkali metals in ammonia solution. So now when alkali metal dissolved in ammonia solution, they give which one here? Alkali metal loses electron and form which one? Cation. Now that cation surrounded by some ammonia molecules and electron also surrounded by some other, which one here? Ammonia molecules. These are called ammoniated cations. These are called ammoniated electrons. So alkali metal when dissolved in a solvent of ammonia, that act as electrical conductor. The electrical conductivity of this solution is due to both that movement of ammoniated cation and ammoniated electrons. So these are called mixed conductors. These are called mixed conductors. So as per electrochemistry, the conductor which is acting as a conductor due to the flow of electrons is called electronic conductor, and in which conductivity is due to the flow of ions, that is called electrolytic conductor. But here this solution is exhibiting electrical conductivity due to the movement of both ions and electrons. So this ammoniate, that means ammonia solution of alkali metals, is known as a mixed conductor, and due to the presence of here ammoniated electron, that means we can call unpaired electron, it is having paramagnetic nature and exhibit blue color, and that exhibit which color means blue color. But on standing, they liberate hydrogen gas, and if concentration increases, if we increase the concentration, the blue color changes to bronze color. That means the color diminishes. What? And that solution becomes diamagnetic. What is the reason? Means due to the formation of clusters. Cluster means here these, as the concentration increases, the ammoniated electrons number also increases, but these ammoniated electrons will pair up and form a paired, that means electron pair. So due to that, what happens? Paramagnetic nature changes to diamagnetic nature, and there is a decrease in contraction of the color, that is called formation of clusters. So this is regarding which one? Ammonia solution of alkali metals. So these are some general characteristic properties of which one? Alkali metals. And another important thing, oxidation state. All alkali metals, by losing one electron, they get into inert gas configuration. So they exhibit which oxidation state? Means common oxidation number +1. Alkali metals exhibit +1 as a common oxidation state. So these are the general properties of alkali metals. Okay, in our next class, let us go for chemical properties of alkali metals. Okay.